Everyone assumes fire gave humans cooking. It didn't. Fire came first. Cooking came from something far more desperate. Hunger, not the hunger of skipping a meal, the hunger of a body that could eat all day and still starve, quietly from the inside. Picture your ancestor 2 million years ago, somewhere in the dry grasslands of East Africa, crouched by a carcass, tearing at raw meat with teeth too small for the job, chewing, swallowing pieces the body barely knows what to do with. This isn't a story about finding food. This is a story about a species that couldn't get enough out of the food it already had. Watch a chimpanzee eat sometime, not for a minute, for hours, nearly 6 hours a day, jaw working nonstop, just to pull enough calories out of raw plants and raw meat to survive until tomorrow. 6 hours every day, just to chew. Now look at Homo erectus, standing near that same carcass, smaller jaw, smaller teeth, and somewhere inside, a gut that was shrinking, generation after generation, at exactly the moment biology says it should have been growing. For any other animal, that would be a death sentence. A shrinking gut on a raw diet doesn't survive. Cows can't do it. Gorillas can't do it. Even your closest genetic relative sitting in a tree eating leaves for 6 hours straight can't do it. So how is Homo erectus still standing? In the late 1990s, a Harvard biological anthropologist named Richard Wrangham sat for hours watching chimpanzees chew, stopwatch in hand, calorie math running in his head. And one question kept circling back, refusing to leave him alone. If early humans had smaller guts, smaller jaws, smaller teeth than apes, how were they getting more energy? Not less. Something had to be changing the food itself. Not the body, the food. In 1999, Wrangham proposed an idea that quietly rewired how we understand human evolution. He called it the cooking hypothesis. Cooking wasn't a cultural invention, something humans stumbled into once they were already clever enough to invent it. It was a biological requirement. The thing that made the cleverness possible in the first place. Here's what happens when meat touches fire. Heat breaks apart the tough protein structures that your jaw and stomach would otherwise have to fight through. It softens starches until they practically dissolve on contact. It does, outside your body, work your gut used to have to do inside it. Cooking didn't just make food taste better, it made your body's job easier. And that single shift changed everything that came after. Because your brain is expensive. Sit still right now, doing absolutely nothing, and your brain is still burning close to 1/5 of your body's entire daily energy. 1/5. For an organ that weighs about as much as a bag of sugar. In 1995, 2 anthropologists, Leslie Aiello and Peter Wheeler, sat with skeletons and metabolic data and found something almost too clean to be a coincidence. Animals with large brains tend to have small guts. Animals with large guts tend to have small brains. There's only so much energy a body can spend. Something always has to lose. For nearly every primate on Earth, the gut wins. It has to, raw food demands a long, slow, energy-hungry digestive system working around the clock. But somewhere in human evolution, the gut lost, and the brain won. Look at a skull from that period, laid out on a table under museum light. You can see the trade written into the bone itself. The jaw is narrower than the ones before it. The ridges where heavy chewing muscles once anchored have softened, faded, pulled back, and the space behind the eyes, the space that once held a brain barely bigger than a fist, has begun to swell outward. Bone doesn't lie about what a body spent its energy on. That trade was only possible because something outside the body was doing part of the digesting instead. Fire. You can feel this, not just understand it. If you think about your own plate, bite into a raw carrot right now and your body has to work. Grinding, breaking, extracting. Now imagine raw meat instead. Tough, dense, mechanically brutal to tear apart and break down. Chimpanzees survive on that. Their bodies are built for the cost. Yours isn't. You couldn't live long term on a fully raw diet the way a chimpanzee does. Not because you're weaker, because somewhere back there, your body made a bet. That fire would always be there to help, and it never developed the machinery to go it alone again. In 2011, a Harvard researcher named Rachel Carmody, working under Wrangham, ran an experiment that made this almost impossible to argue with. She fed mice identical food, same ingredients, same calories printed on paper. The only difference was heat, some meals raw, some cooked. The mice, eating cooked food, gained more weight, extracted more usable energy, spent less effort doing it. The food hadn't changed. What changed was how much of it the body could actually reach. That's the quiet, uncomfortable truth sitting underneath this whole story. A calorie on a label and a calorie your body can use are not the same thing. Cooking is what closes that gap. Now push the timeline back further than most people expect. For years, scientists placed controlled fire use around 400,000 years ago. Then in 2012, a researcher named Francesco Berna went digging inside Wonderwork Cave in South Africa, and what he pulled out of the sediment pushed the story back nearly 1,000,000 years. Burned bone fragments, ashed plant remains, sealed deep in layers of cave floor. Not signs of a wildfire that swept through once and vanished. Signs of fire that was tended, fed, kept alive on purpose. 1,000,000 years ago, someone who would barely be recognizable to you, smaller brow, heavier jaw, no language you'd understand, was already sitting by a flame they had chosen to keep burning. Not for warmth alone, for food. Think about what that means. Long before language as you know it, long before art on cave walls, before tools sharp enough to call weapons, before anything you'd recognize as culture. Someone was already crouched by a fire, turning raw hunger into something their body could finally use. Close your eyes and put yourself there for a second. The dark pressing in on every side. No streetlights, no walls, nothing between you and whatever moves in that darkness except a small circle of orange light. Someone feeding it a branch. Someone else watching the shadows past its edge. And in the middle of that circle, meat that had been tough and gray an hour earlier, now softening, changing, becoming something the body could finally break down without a fight. That act, small and unrecorded and completely unremarkable to whoever did it, may have quietly rewritten what your entire species was capable of becoming. More usable energy meant energy left over. Left over for a brain that was getting more expensive with every generation. Left over for a body that no longer had to spend 6 hours a day just chewing, which meant something almost nobody at that fire could have understood they were creating. Time. Time to sit still after the meal instead of immediately searching for the next one. Time to watch the flame instead of just using it. Time, eventually, to wonder. You don't usually think of a warm dinner as the reason you're capable of reading the sentence, following it, turning it over in your head after it ends. But somewhere in that long chain, a shrinking gut, a softer meal, a flame someone refused to let die out, sits a real part of why your brain had room to grow into what it is. Not intelligence first, energy first, intelligence came after. Almost as a side effect of survival arithmetic nobody was doing on purpose. Here's the part that stays with you longest. You didn't start cooking because your species got smart. You got smart, at least in part, because your species started cooking. The order most people assume is backward. Fire didn't reward a species that was already brilliant. Fire built the conditions for one to exist at all. Tonight, when you sit down to something warm, something so ordinary you won't even notice yourself doing it, you'll be repeating an act that quietly shaped the size of your skull, the shortness of your gut, the entire structure of how your day unfolds. Somewhere back there, in the dark, near a fire that had to be watched and fed and never left to go out, someone was hungry in a way you have never had to be. Not hungry for food, hungry for enough, and the fire they built to answer that hunger is still burning, in a way, somewhere inside you, not in your stomach, in the 3 pounds of thinking tissue that hunger once made room for.